But what if we want to grep for multiple files or search inside directories? There are a couple of ways to do it. One is we could just say, well, grep for Apple inside and then provide the file path, a directory in this case. So let's just say we're going to use the current path. The dot represents the current path. We could just as easily type users, Kevin, and then Unix files, same thing. Comes back and it says it didn't find anything. It's because we've given it a directory. If we want it to do it this way, then we need to put the -r option in front of it for recursive. Recursively look inside here, meaning check all the files that are in this directory and then go into the directories below that and look inside those and so on. It's the same option that we used with copy, move, and remove earlier. So grep recursively for Apple inside this directory. So whenever we use a directory, we want to use -r, just like we did when we were doing copying. So now it tells me not only the matches it made, but the file where it occurs. We could also provide the -n option after that, and that'll give me the line numbers in each of those files. Notice that it does this by default. It says, now because I'm searching multiple files, I'm not just going to give you the results, I'm going to tell you where I found them as well. You can suppress that. Let's just erase all this, and I'll just use the dot from now on just because it's a little bit shorter. And instead of the N option, let's use the H option. H option will suppress the file name and still show you just the line itself, or if you wanted the other way around and you wanted just the file name, you can use the L option. Now it tells me, I found Apple in 3 files, fruit, sorted fruit, and unique sorted fruit. That can be really handy, right? You could say, all right, here's the relevant files, I found them, and now we could potentially pipe those results into something else, right? Maybe we want to now concatenate these 3 files. After we find them, then we could potentially concatenate them together. If we want to do the opposite of that and find the files that don't have a match, it's the capital L. So that returns all files that did not match. This is very similar to the -v option that we did earlier, but that returned the lines that didn't match. This is returning whole files that don't match. So it's similar, but not the same. Now this recursive approach, using this R option, is searching all files in all directories. Don't forget that Bash also lets us use wildcards to try and pick more specific files, and that might speed up our searches. For example, just using ls, we can do ls asterisk txt, and we can see just the text files that are in the current folder. Or even more specific, we can say, all right, let's check just the fruit files, right? So now I'm seeing just the fruit files. That wildcard lets us do that. That's handy with grep, because now, for example, we can say, well, grep for Apple inside just the files that end in fruit.txt. It's the same results that we got, but it's just searching these 3 files instead of searching every file and directory. If you have a lot of files and directories, this can be a lot faster. But the main point is, don't just choose recursive by default. Think about what you're really trying to accomplish and try and find the best way to do that. Now these are working with files and directories. We also can change our standard input. We can use piped input. We could, for example, do cat fruit.txt and pipe that into grep for Apple. That's still just working with a file though, right? It's just as easy to do it the other way. Where it's really more useful is with something like psaux. You'll remember that that returns a list of all of our currently running processes. Well, we can grep that list. Let's grep for terminal. There is my entry for terminal. I can now see what its ID number is. I can see how long it's been running. I can see how much memory it's taking up. All of that information just by grepping for only the line that contains terminal. Or we could say, all right, show me everything that has applications in it. So now all of my Mac applications will show up and I can see just those and not have to sort through that whole list of running processes. Another place that it's useful is with the history. So for example, let's say history, and let's grep that for Unix files. Every time that I've made reference to the Unix files directory, we also could then use this as shortcuts to be able to run those commands. We saw how to do that when working with our history. Let's try history, and let's pipe that through grep nano, and then pipe that into less. Now I only have a few, but if you had a lot of these, we now would have a paginated list of all the times that we've ever used nano. So we pipe our history, filter out so that we get only lines that have nano in it, and then use less pagination.